This is a very large farmhouse, and when we first moved in it was in a very primitive state, and the only source of heating was 4 inadequate electric storage heaters. Most of the heat was dissipating because the insulation and so on was inadequate. We've always liked the idea of high temperature heat sources, radiators in each room that you can approach to get warm and move away from to get cool. And we wanted a heat source for a wet radiator system of that sort. Initially we looked at all the contenders from renewable energy sources. We looked at wind power, but we're not in a very windy area towards the bottom of a valley, so we ruled that out. Ground source would have involved too much expense in insulation of the pipes. We looked at air source, but I've always had reservations about the possible noise levels, so that really ruled that out for us. So we were looking for a suitable high temperature system, if you like, to power a conventional wet radiator system. However, we were lucky in finding a local contractor who knew the house historically, who I know had a particular interest in seeing the house restored as much as possible to the way it had been, and this is the approach we've taken. We also like the idea of the old-fashioned kind of heat where you have perhaps an open fire that you can sit around and toast yourself in front of, and with modern log burners that now becomes a viable and pretty efficient heat source. We also wanted to run cooking from wood, and we've managed to incorporate now a very efficient wood-burning cooker which also heats part of the water. So we really have a three-pronged approach now. We have a wood-fired cooker which is heating some of the water. We have a pellet boiler which is providing the main heat input for heating and hot water, and we have solar which is providing a background heating of preheating, if you like, of the water. But all those systems are linked into one central heat store, an accumulator, if you like. We're in the boiler room now, and this is the hub of the pellet boiler system. There are really 3 components to it. The boiler itself, with the burner which is at the bottom there. This is the hopper, the pellet hopper, which stores the pellets, which are then fed up through the auger and dropped down to the firebox below. The boiler itself has its own water jacket, which is about 220 litres, and that water is in circuit with the third element of the system, which is the heat store. It's a large accumulator tank, 750 litre capacity. So what happens basically, the boiler lights itself, heats the water in its own water jacket. A pump circulates water from the water jacket in the boiler through the accumulator tank and back again. So that's continually, it's a shunt pump continually running, transferring the heat from the boiler to the accumulator tank. The accumulator tank is a very large store of heat for whatever purpose we may need. This may be for hot water, it may be for heating. So we have actually 3 coils in the accumulator tank. The coil at the bottom introducing heat at the bottom from solar panels. 2 further coils halfway up and at the top are related to the hot water systems, but the whole system is fully automated. So we have a conventional programmer on the wall there where we can specify what times we want to have hot water and what times we want to have heating. This is actually finished construction, but it's very efficient in the way that it burns, and you can tell that really by how little ash is created. The makers recommend that you empty the ash pan once a week. We find in practice we only need to do it about once a month. And you can see actually this was last emptied nearly a week ago. That's the amount of ash that's accumulated in that space of time. I think the burning efficiency is well into the 90%. We're burning wood pellets and we buy them bagged. I think the options are that you can buy them either in bags or you can have them delivered in bulk. If you want to have the pellets delivered in bulk, which is a little bit cheaper, you have to have a dedicated bulk storage room. We didn't have that space available, so we opted to have a reasonably large hopper like this one to store the pellets. When the weather is very cold, last winter when we had no other heat sources, we were consuming something like 4 bags of pellets a day. The cost of the pellets just over £2, about £2.25. So let's say £9 a day. Through the summer, with the help of solar heating, we have been consuming approximately half a bag of pellets a day, so probably something like £1 a day. That has been our total heating cost. This will hold approximately 50 10-kilo bags. So at our peak usage, that would last us, let's say, approximately a fortnight. In the summer, this might last us several months. The burner here has a capacity of 30 kilowatts, and that's adjustable. We've found that although we have 18 radiators and a lot of bathrooms, we've never needed to run this at more than about 15 kilowatts. I think one of the most important things about this sort of system is the overall system design. A part of that process has been upgrade the insulation from scratch, replacement of the windows, double glazing, draft proofing of the doors, insulation in the loft, and we've used actually recycled plastic bottle material. When we look at the cost of all the systems that we've installed, I think it would break down pretty much like this. The raw cost of the pellet boiler, the accumulator tank and the hopper, approximately £7,500. The cost of the SE wood burner would be approximately £7,000. The cost of the 12 kilowatt log burner, that would be approximately £2,000. The solar tubes, about £3,500. So the total installation of all those features, I'd estimate, I can't give it to you exactly, but I would estimate approximately £30,000. We are looking at the possibility of using photovoltaic electricity generation in the future. That's one thing I might have thought harder about early on. With regard to the pellet boiler, I might have looked a bit harder about the possibility of building a dedicated pellet store rather than the hopper system. That's something that other people might want to consider. I think when you look at the performance of the system, it's quick to respond on a very cold evening. At the flick of a switch, within 15 minutes the whole house is warm. I think it's been very important to have spent the time getting the system very carefully designed. So we've got the solar preheating the water in the heat store. We've got a log-fired cooker in the kitchen providing some hot water, but that's linked into the pellet boiler system so that if we run out of wood, we can draw on the pellet side. If we run out of pellets, we can put heat back into the system from wood. But getting those systems to work like that does require careful planning by a plumber or a heating engineer that knows these various technologies, not just one. You need somebody that has an overview of how these things interplay if they're to work successfully, and I think we've been lucky in that respect in finding the right contractor or contractors to get that set up. If I were to estimate what the running cost of, say, an oil-based system for hot water and heating here would be, a house of this size, and it's pretty big, would, I'm quite sure, cost us between £5,000 and £6,000 a year. I think that our total running cost would be about £2,000 a year. So we're really looking at gross savings of approximately £3,500, maybe £4,000 per year. So quite a lot of savings, and which are going to continue year on year. So we're pretty pleased with the decisions that we've made in trying to get away from the fossil fuels.